For today's lecture, there are 3 documents that you will be given. Those documents are already on their way to your class rep or whatever way we communicate with you. They are also available on our website, but in case you find our website too difficult to navigate, the 3 documents that are relevant to today's class are given to you. One is the lecture slides themselves, which unfortunately is in PDF form. I've not been able to find it in the PowerPoint form, so I can't edit it. So there are errors on it, which I will talk about when we are going through them, but which unfortunately I cannot edit because it's in PDF form. So that's the first set of slides, basic sketching in the GUI. So that's what we're going to do mainly in the first part of today's lecture. And then after we have gone through that, we're going to be specific. In doing the basic sketching, we're going to take you through how to make a simple connecting rod, which is essentially based on circles, lines, making tangents, making mirrors, doing simple extrusion, and working with a 2-dimensional sketch to create a 3-dimensional object. So we'll do a practical demonstration of that. But because there's a demonstration of that in class may not be fully satisfactory, so I have made a 10-minute video of the whole thing, which I did on my own time, so that you can watch the 10 minutes video and you can go back and forth. The reason for this is that sometimes, because of Zoom, the images that we post on Zoom may not translate very well when it reaches your download to your system. So, but if I have an MP4 file, the MP4 file is something you can use directly, and it is going to it's going to appear to you exactly the same way it appears to me here, so it's more accurate. And then 3, we're going to show you the full internal combustion engine graphics, which includes a component design. So we have 4 main components. We have the engine block, the connecting rod, the piston, and the crankshaft. And then with the rotor and everything, and we will animate them. So we are showing you that for you to see what you will do in your later projects, the kind of thing you are shooting at, so that when we are building different parts, I want you to be able to combine them together into a working model of something physically significant. So instead of just you're doing very simple things, you want to combine those simple things together to make a whole. That is what engineering is all about. You are not just doing a connecting rod, a lamp. You want to see how all those things make up a physical or a physically useful object. So we're going to take some time out to do that. But the video you are going to be given is just to give you an idea of how it works, so that you know precisely which direction we are going. And maybe that will be, maybe some of you will find that inspiring. But let us get to today's class. And as this being the first class we are going to have in the online platform, I want you to note that there is a chat room going on as we are moving. Sometimes I will ask you questions and I will pause. I will tell you to go to the chat room and give me an answer. It is in your own interest that you give me answers, because there is a 5% grade that is going to be based on your class participation. That class participation is worth 5 marks. I don't give free marks. I don't add marks arbitrarily to students. If you want to be treated kindly at the end of the term, when you are on borderline, if you miss out the participation marks, that could be the difference between you and failure in this course. So if you have those 5 free marks, that means that if you have 5 less than the passing grade, you will be okay. If you have 5 less than A, you will still get an A. If you have 5 less than a B, you still get a B. So, and how do I measure this class participation? I measure the class participation by taking a record of all your contributions during the class, and those contributions are the contributions you make on the chat room. So in the chat room. So we are monitoring it, we are recording it. So if anybody wants to know, we can show you that you have been lazy, you have not been participating. To participate doesn't mean you have right answers. It just means that you are trying, you are giving your opinion, you show you are awake, and you are attending the class, because there is a minimum number of classes that you need to have in order for you to even be qualified to sit for the final exam. And like I told you when I met you last week, you should keep a catalog of all the drawings you do, because you'll be required to bring them to the exam hall in the final analysis. So you will need them. So that is something I think you should be aware of. So let us move on. So before I want to give you your first project now. You look for a concrete bench on campus. It could be, I prefer a bench that has been broken down, because if you take a bench that has been broken down and then you design what the original intention of that bench is, eventually, when you get to a level, may not be this year, it may be at the subsequent years, you might be able to simulate and see whether that failure could have been predicted. But you should I will give you my own bench, but don't go and take your own measurements. Don't be lazy and just depend on my measurements. And so you do a 3D solid model of the bench to the example given in the lecture. Do not use my fully developed example. And now, the due date here, I should be able to change the due date, but I can't. So let us see what the due date should be now. We are in May. Let me see. What May? What are we now? Yes, we are in May 28th now. So I think if we give you 2 weeks, that will take us to, let's see, let me just see what 2 weeks will take us to. 1 week will take us to that is June 11. So the due date for the first project is June 11. So anything we are doing, try and understand enough of it to be able to do that project, because that project is going to count in your final grading of this course. So you submit your drawings online to the admin, and you keep a copy of your submission. Submit and keep a copy of your submission, because in the final exam, I might actually ask you questions that require you to use, you may have questions that require you to use the drawings you have already submitted. Setting preferences. There are several things when you get to the Fusion 360 environment. There are several things you can do, but there are certain assumptions that the system will make. For instance, it's drawing in 3 dimensions, X, Y, Z. And now, some people are used to the Z-axis being the vertical axis up and down, and some other people are used to using that as a Y-axis. But Fusion 360 doesn't care. So you set which one is your Z-axis. Is it Z-axis up, or is it Y-axis that is up? All those things you can do in the preferences. I will show you with the demonstration how to get to the preferences, but let me just explain it for now. Fusion 360 allows us to set several preferences to govern the graphical user, to govern how the graphical user interface GUI behaves. One way to reach these settings and make them suit your way of working is to set preferences. A look at the application bar, which is the top bar. Look at the application bar and go to the right side of it. This is how it looks. When you launch your Fusion 360, the place where the arrow is pointing is where you can set your preferences. At that top right corner, one of it will be either your initial, one of the icons you see there, almost to the very right, will either be your, depending on how you are set up, is that your passport photograph, or if you don't have a passport photograph already there, it could be your initials. So let us say your base name is Babatunde Ojiji Koko, so it will just be BO. If your name is Ifeoma Kenechuku, your name will be IK. So that your what that is the place that is important. And there are other things that you can do there. And then just below it, just let us navigate. Let us just look at what you are presented. Just below it, you have what is called a view cube. The view cube is one of the most important things you are going to be using. The view cube helps you to view your three-dimensional drawing and to get back home. To get back home is to get you to the origin of the drawings and put it in the original perspective of your projection. You can move away from that, but no matter where you go, you can, in a single click, come back home. So what is on top there is called the applications bar. On top, on the left of the applications bar, you have your ability to save your file, and then to see all the drawings you have done before, and so many other things. And then immediately below that, you have your workspaces and tools bar. Your workspaces and tools bar will show you what kind of workspaces you have. Usually in this class, we are going to be in the design workspace, but there are other workspaces as I will show you when we get there. I'm sure you should have seen. Depends, the workspace you go into depends on what you are trying to do. And then there is another set of icons that help you to create things. You might be able to create a sketch. You might be able to create a solid object through extrusion. You might create one through revolution or through revolving, and several other things. You may also want to work on surface patches. So that is that. And then another set of icons helps you to modify what is already there. So you have the modify set of tools, and then after that you have the assemble, the construct, the inspect, the insert, the select. All those things are part of the workspaces and tools bars. Then below them on the left, you have the browser. The browser gives you important information about what's going on in your drawing. The browser gives you important information on what's going on in your drawing. It's often very informative, and the browser can come to help. Sometimes when some things happen, you will see that when you are doing your extrusion, you might want to do 3 extrusions, for instance. And when you finish the first extrusion, your sketch that you are using to extrude just disappears. You will not need to panic. You can go to the browser and turn it back on if that happens to you. So the browser can be and the browser gives you important information on what is happening on the canvas. The large space where you are seeing the 2 big eyes right now is called the canvas. That is most of the time where you are going to be putting your objects. And then below, there is the timeline. Unlike Autodesk AutoCAD, the Autodesk Vision 360 is a time-bound drawing tool. So what you are drawing, the time you finish every component, every item will be placed on the timeline, and you can play them back like a movie at your own given speed, or you can move step by step through them and take a look at them at a later date. Unfortunately, and I do not know why this happens, many times we spend a lot of time on the sketch, but the timeline, as far as I can see, as far as I've been using this for some years, it does not play back the sketch. And that's something that I think should have been allowed. But it doesn't play back the sketch. But you are lucky because this lecture is being delivered online. You can play back the sketch by just playing back the video if you download the video. And last thing I want to talk about on the page is the navigation bar. The navigation bar is below here, and that navigation bar, from there it helps you to look at your drawing in different ways, and to move to specific places and to move to specific views. It can also help you to determine whether you are going to have grids and you are going to have snaps. So you might be able to snap to a grid if you want that. You may be able to use a grid. You may be able to refine a grid or make a grid more coarse. All those things are all you might want to zoom in or zoom out. and you might want to take a perspective view or an orthographic view. All those things are possible in the navigation bar. And just to get us to the first test on your chat room, I want you to go to the chat room and tell me what you understand by perspective view or orthographic view. I want you to know. I want to know whether you know what those things mean. If I find that you don't know, then I will have to explain it to you. So, do you know what is meant by orthographic view as distinct from perspective view? So, go to the chat room and talk to me. Talk to. So, yes, I want to hear from you. I've only heard from two people. I've not heard from the. Okay. I've not heard from the rest. I am not impressed by the level of response I'm getting. One, two, three, four. Want to see? Just want to know what your views are, so that I can see what. Okay. Okay. It's good to see what your thoughts are. Mhm. Okay. I hope everybody in class heard me when I told you that how much participation you do in the class is going to be recorded, and we are going to determine your participation at the end of it. Yes, somebody has copied something here. Orthographic drawing in engineering is a method of representing 3D. It shows Chidera Anozie, you are a good lifter. Good. It shows the true shape of a size of an object. Well, I hope you are reading it. You are not just copying it and pasting it for us only. I want you to talk to me, and I'm not saying I don't have any problem with your using AI or anything, but just make sure you can. Yes. Now, I am happy with what you people are doing. Some people didn't know, so they went to their computer or their phone to put it in. So the perspective, both of them, somebody says it's perspective is 2D or and then orthographic is 3D. No, it is not the matter of dimensionality. It is that the perspective tries to give you a human eye realistic view of the object. So, whereas the orthographic view gives you an accurate, measured view of the object. So, if you have an orthographic view, you are going to see the lines in their correct lengths. Whereas in the orthographic view, you are going to see, and in the perspective view, you are going to see the lines. There will be a vanishing point where where your eye is going to see a point, and everything just expands out from that point. So that is the thing. So you can set that's good enough. So you can go back to your work now, and let us continue. So so most of you understand, and what I'm happy about is that those who don't understand can go and use their computer or their Google or AI chat box to find out what those things mean. So I encourage that. If you do not, if you hear a big word, you don't understand it, check what you can get about it. It may not always be perfectly accurate, but it will give you an idea, and it will be a good place to start. So the navigation bar, I will show you how you can set your view, whether you want it in perspective or in orthographic, and you will be able to see, you'll be able to decide for yourself which view you want. There is no correct view, so it's whatever you like, you choose in that case. And then, so I can move to the next page now. There's the name drop down at that end there, where you can, on the right side of the application bar, you'll find 6 icons where the arrows point, 2 of which should be The question mark, help icon that assisted you to reach your videos as explained in your first class. If you hadn't installed, you might have reached those same videos by the web link that I gave you, or you could reach those videos straight from your Fusion 360 application if you installed correctly. Your name or picture icon, depending on the details you have already included in your settings. I've already talked about that. These are both to the right of the others. If you click the name icon, you will see a drop down. Autodesk account has highlighted preferences and so many things that will be there. So that is the one where that's of interest to us now. You may have noticed, for example, that my display screen shows my passport photograph at the corner. If you are eagle eye enough to see, because I myself can barely see it when I'm working here. And these are several other, you can have yours behaving that way too. These are several other things can be done by clicking either the edit pencil or plus marks on the right to against any modifications you like to effect. So there is a plus sign and an edit pencil on the other side, on the right side, which you can make. You can see that plus sign, which is an edit pencil, depending on the version you are using. So the next page shows you my own dialog for this. The number of things you can edit continues as you scroll further down the page. It's up to you to decide how many things you want to add to your account. Be accurate and professional in doing this, as the association may last long. And then, so these are some of my own editings, and you can do your own. And then the name drop down, preferences. Selecting the name drop down again can be used to get to the preferences settings. Click the name icon and you will see the drop down shown and look for preferences. When you get to preferences, again, very shortly, I'm going to do a demonstration of all these things for you. These are just clips that I made when I was doing them at a particular point. I will demonstrate some of these things. For instance, the one I say demonstrate, which I will demonstrate for you, is show tooltips. If you mark that, that means that when your mouse is hovering around an icon or a drop down, there will be a tip that will be shown to you to tell you what that particular icon or idea is meant to achieve. That could help you in case you forget. And there are just too many things to know. If you attempt to memorize the things that are here, you are not doing yourself any good. You shouldn't be trying to memorize. You should just be using these things, and some of it will sink into you as a result of use. But if you're trying to be memorizing, I'm not going to ask you anything in memory. Everything about this course is going to be practical, and you are going to do something. For instance, you will see where I'm putting my mouse here, Z up. That Z up, that means that here we have chosen Z up. If you click that drop down, you'll see that you could also have chosen Y up. It only allows you to either put Y or Z up. We know that X axis is always horizontal, but Y can be vertical, Z can be vertical. So when you are in 3 dimensions, it depends on how you want it. There are textbooks which make Y vertical, and there are others which make Z vertical. I choose Z to be vertical for myself, but you are not constrained and you are not compelled to do the same thing. You'll see that in this general preferences of the UI, you can see that you can choose which language you are going to use. I'm not sure Yoruba is there, but it would be a nice idea if Yoruba is one of the languages. You can select your graphics driver, because some people have several graphic drivers on their computer, and it can now allow them to select. And there are other things like the offline catch, skip launch items, in creation, update. There are so many things you can choose. And if you go down, you can see the API, design, manufacture. I'm going to go through this again when I actually do a demo in the next few minutes, because some of these things are better done by demonstration. And those of you who have your computers fired up, you can actually be testing these things out, and you can have good questions for me as a result of your effort. Workspace preferences. The general selection of the preferences, as we have seen, applies to the interface. There are groups of preference settings that are specific to individual workspaces. Others go beyond the user interface, the GUI, to the programmer's interface. Like I told you last week, There are two ways of interacting with the engine of Fusion 360. The engine of Fusion 360 is there. You can use the graphical user interface to interact with it. You can also use the applications programmers interface to interact with it. Or you can use both. I think the best result will be to use both, because there are some things that are very easy to do in GUI, and programming may be a little bit difficult, but there are some things that it's only programming that can do it satisfactorily. If you try to use GUI, you are not going to get it accurately. But again, you can. We are going to teach you both in this class. So here, for example, you can select the language to be used for programming scripts or add-ins. So you can decide whether it is C++ or Python you have. Before there were more than 2 languages, but I think they've discontinued the third language now. So there was a scripting language that they used before. I don't think they're using that again. Like I said, for our course, it is Python we are using. If you want to use C++, you are on your own. I'm not going to give you any assistance. Not because I don't know C++, but because it is just too hard for something simple like this. The choice of Python for this course is for simplicity and leveraging to other uses such as AI, machine learning, data analytics, and other emerging knowledge areas that may become important to you. Notice that even though this thing is given to you in context of engineering graphics, computer engineering graphics, you can do virtually anything you like with it. You can draw a bottle, you can draw your cup, you can draw even human beings, and anything you like. And I might be able to show you before the end of our lectures that when I was designing my own house, I used the 3D solid modeling to design every room, everything in context, and you can view anything you want. You can view even the reinforcement or the foundation and so many other things. So you can do anything that you want. And I think it is a good idea for you to be creative, because as you are creative, you might actually have a business model on something you can do for other people and make money out of it. And that is greatly encouraged. So you can set for the API, where you set languages and other things. You can set for design, where you set the kind of component bodies and sketches, the way they relate to each other. You can also set the units of measure. For instance, if I say I want 30 units, those 30 units can be 30 millimeters, they can be 30 meters, they can be 30 miles, they can be 30 feet, they can be 30 inches. But there's a place in the preferences where you are allowed to say, okay, when I do not specify what units I want to measure in, make it millimeters. And so if I just say 30, it knows that I mean 30 millimeters, and so on. So those are things that are, so there are groups of interface and preference settings that are specific to individual workspaces. Others go beyond user interface, GUI, to the programmer interface. Here, for example, you can select the language you use and so on. So we can move to the next page. Adjusting the GUI settings. One of the first things you do in Fusion 360 is to customize the interface and environment to suit your way of working. Make yourself comfortable. Your settings can be different from others, and you can change them easily and to become more comfortable on the fly. Do not memorize, just do it. Just do it. As you keep doing it, you will know how to do it. If you want to memorize because you are looking for shortcuts, it's not going to pay you in my course. So let me just warn you ahead of time. It will not pay. What will pay is that you do your work. You do your work. You need to come to a particular percentage of the classes. You need to participate in the chat room when I ask you questions. And you can go to the chat room on your own and ask me questions. There may be other lecturers who attend this class because they also teach it in other places, and they may help you. And we have assistants. There's Mr. Gudero, who is also your lecturer, who will be available to answer your questions, and we take some of your tutorials as down the road. So, and then your other classmates, even the first question I asked you, I could see that as some people were saying, well, I don't know. Some other people are saying, well, they are ready to help you. So if you ask a question, it doesn't, maybe I will look at that chat room every 30 minutes, but your mates might have seen it and I might have answered you before I got there. And at the end of the class, I would look at the entire transaction in the chat room, and there I will be able to see what questions have not been dealt with, and I may still answer it, either by sending you a note to the class or by taking it up in the notes of the next lecture. So this gives you a foolproof way of making sure that any question that is really bothering you can be asked. So look at the initial display as it ought to appear upon starting. Find the navigation panel. There's a navigation panel centered at the bottom of the screen. This is designed to help you control the graphical user interface settings. And you look again, you see here, you can see at the bottom center of your screen. That is where the navigation panel is. There are several. In here, I can see 1, 2, 3, 4, 5, 6, 7, 8 icons there. All of them, play with them and see what they do for you. I will demonstrate some of them, not all, before the end of the class. It's called you can call it navigation panel or navigation bar. So just look at it. And so I've decided to describe 4 of them here: orbiting, looking, and panning. There are 2 ways to use the orbit icon. Select it, and your drawing will orbit around a point or a line to show you more of the same. So you might want to have a 3-dimensional drawing. Let us take the bench, which I'm going to use, and you want to see what it looks like under, because you have a 3-dimensional figure. So you can look at, there will always be some parts that are hidden. You might want to look at those parts that are hidden. And then you can do that by orbiting. So the free orbit is supposed to be different from the constrained orbit by allowing you to orbit unconstrained. And then you have a look icon, which is very nice. This icon allows you to look at faces and different parts of your graphics on the fly. I will demonstrate this shortly. And then there is the panning tool, which lets you pan. You can, because sometimes you do not see the whole drawing and you want to pan either up or down or left to right. The pan, like a hand tool, that is helping you to shift the drawing so that you can see. Of course, you can also use zooming in and zooming out, but sometimes you do not want to change the scale of the drawing and you want to see things without changing the scale of the drawing. The panning thing can be very handy for that. Orthographic and perspective views. As an example of the possibilities of a navigation bar, we will demonstrate the following. You choose an orthographic camera in the camera setting. So I will show you how to choose an orthographic camera, and then I will show you how to use the look at icon to examine a side of, say, the bench. I will bring this bench in my own drawing out, and then you will just take a look at it. And then you can look at the same side of the bench, change the perspective so you can look at it in 2 perspectives to show you how those perspectives behave. And then there are tons of things you can set in the display settings. Consider the ground and the ground shadow. So you can have a situation where there's a shadow, and you can have a situation where there's no shadow. So it's all effect. If it helps you, if you like it, that your 3-dimensional drawing shows a shadow, does an imaginary sun that is shining on the object and creating a shadow to make it more photorealistic, that's up to you. In the effects option, you can control both the appearance of the ground plane and whether a shadow should appear or not. The picture on the left shows both the ground plane and the shadow. Now attempt to remove the ground plane while the shadow is still set to be shown. You cannot do it. It knows that you need a ground to show a shadow. So if you remove the ground setting, then there will be no shadow. Because if there's no ground, if your picture is hanging in the air, then there's nowhere to place the shadow on. So it's try to be photorealistic. And also, you will see that when you begin to simulate, your Fusion 360 understands physics. It understands physics. It knows that if you drop something, it will go down. So if your z-axis is up, so if you leave an object at the z-axis when you are doing the simulation, it may be acted upon by gravity and it will fall down. So that will come in the simulation direction. So that's why it is important for you to decide where is your up and where is not your up. That if z is up, then that effect will not happen if you move something along the y-axis. But if you move something along the x-axis and you actually allow physics to operate, you will see the thing being acted upon by the acceleration due to gravity. So that is still far in front of us. It's not what we are doing today or in the next few months. It could not even be in this course. It will be in later courses that are based on this. The thing about it is that if you do this well, later subsequent courses can be based on what you already know here, and that is how your understanding and learning can actually be greatly enhanced. Component-based design. The bench, as shown here, is an example of component-based design. For instance, you can see that the arm is in red. The bottom there, I'm colorblind, looks like pink, and the bench you are sitting on looks yellow, and the backrest looks green. This is the kind of thing you have when you do a component-based design, because when you do it in component basis, it's so easy to replicate. For instance, you can decide to bring 10 of these armrests because they are the same component. You can bring them, you can rotate them, you can arrange them, and then so that instead of having to draw another one again, you just know that it is a named component. You can say, give me another piece of that component, and that's it. The ground support is also a component, and usually Fusion 360 can help you automatically color your components differently so that you know one component different from the other, or you can overwrite that and choose the component color yourself. In fact, you can choose a component color based on the material used for the component, especially if different materials are used for different components. For instance, if you say that this armrest is concrete and this is wood, those two things already select what colors that you will have. So, so these colors may not be arbitrary, and they may or may not have anything to do with the reality of how the thing will look at the end. The inspection color coding shown here makes the different components explicit. So it will rotate the colors so that you will know what component is what. These are the arm, base, bench, and the back seat. Those are the components that are here. Those are all the components you have, because even when you go to the other side, it's a repeat of the base and the armrest. That's all. Each component begins with a sketch, and in this case, the third dimension is created via extrusions in the four components. Extrusions are not the only thing we can do. We can, in Fusion 360, we can do lofting. We can do, apart from lofting, we can also make something to move along any particular line. You will see those things later on when we go back. Why we can create such we can create such in situ. Fusion 360 comes with a powerful assembly ability that it does not matter where you create something. You can decide to assemble, and the assembly power is in what it is in a facility called joints. When you create joints, you can decide what motions those joints will have, and that will help you to assemble stuff. I'm sure we will get to assembly in this work. This is, for example, what you have here is the two-dimensional sketch that I'm using for the armrest, and it has all my own dimensions. You can play with this, but you cannot submit it to me because this is my own drawing. This is my work. You can't steal my work and then tell me to give you credit for that. So you go out there and do your own measurement of other things. In fact, you get extra mark by doing something differently from what I have done. Use what I have done to understand how to do things, and now show me creativity from your own perspective. Show me some creativity, and get yourself some tape rule, get yourself a vernier caliper that is digital, as I told you the last time, and some basic instruments that are your own. Put your name on them and use them. Go out there and take your measurements. And take your measurements, and that everything will be fine once you know how to measure. This is my own two-dimensional drawing, and you will see how from there later on I can make the three-dimensional figure. The fully dimensioned arm of the bench may appear complicated. It is not. You need to adopt a sketching strategy and make use of the sketching tools provided as you add sketching features. It all begins with an accurate set of dimensions and on a hand, sorry, and a sketch that you have at hand. So you can do a rough sketch, and then you go there, and then after some time you come and do your accurate sketch using Fusion 360. And when you do that, remember you have 2 weeks to get your. I want you to take one of the things you do. You take a photograph of the actual bench that is motivating your own design, and you are going to do a good design, and then it may be that you want to study why that bench failed, and then you just make an accurate drawing of it. And your accurate drawing, as you will see, would include the reinforcements. You see the reinforcement inside, we can look at it. It will be inside, made of steel, which is a different material and will be a different component than even the component is sitting inside. And you will see shortly that we can make in our drawing, we can make the object itself transparent so that we can see the reinforcements that are inside. You can do a rough sketch. For instance, this is a very rough sketch of it, and it's nice. You can start with something very simple before you even do something that is accurate to what you are. Just do something simple. Be sure you get your hands dirty and you really know what to do, and then you can continue improving. It doesn't have to be perfect the first time. So this is another example of the dimensions you can take, and just do your measures. And you can also get a meter rule, and that is something you can do. And it's something that is an angled that you can measure angles also. So this is yet another sketch. You can create and modify sketches. I will show you how to create, modify sketches, and constrain them. This is another example. Another example is a connecting rod that is inside internal combustion engines. So this particular one, I will give you a full demonstration of this today. This one is done. This is the full dimensioning of this particular thing. And on the right-hand side, on the left-hand side is the dimensioning in the two-dimensional picture. And on the right-hand side, you have the three-dimensional object that was created from the two-dimensional object. So you have a two-dimensional object, and you can create a three-dimensional object from it. Usually most things start from two dimensions. You will see later there are certain things that you can do straight three-dimensional from scratch. But for most of your drawings, you start with a two-dimensional drawing and you then move to 3 dimensions. In this particular case, I do this. This is my own method of doing this, is to use 7 circles. One circle, 3 circles at the origin. There are 73, 60, 50. I don't measure you the dimensions because my own dimensions are always in millimeters. And then there's another circle at 180 millimeters up. And there are 2 circles there. One is 32, the other one is 15, as you can see. And then you may not see, there are still 2 circles. One is 20 units at 50 millimeters up, and then there's another one that is 10 millimeters at 150 millimeters up. All those kind of things are done, and you will see how I use those circles to create this figure so that you will be able to see some of the issues, some of the facilities in drawing objects, in making tangents, and then dimensioning, and so many other things that you can do. Mirroring, for instance, mirroring when there is something, when there's symmetry. If you do something on one side, you don't do it again on the other side. You just take a mirror of it. And Fusion 360 is excellent at taking mirror images so that you do not waste your time. So if something is already done correctly on one side, you'll see the mirror of it on the other side. And then you can do a path, and then you can trim, you can cut off unnecessary parts. Let us say you draw a line and the line is too much. You can trim off the excess line, and you can have another line cutting it. And then you can do construction lines. We will see how we do how we get a line and turn it to a construction line. And then you will see how to place your dimensions. Both linear dimensions and angular dimensions can be done. And you also check how to do constraining. For instance, you can decide that you have these 3 circles and you can constrain them to be on a vertical plane, and on a vertical, the centers to be on a vertical line. So that you don't have to manually find your own way of putting them on the vertical. Tell the thing to put them on a vertical line, and then they will be made vertical to each other. And at every point in your drawing, the origin is always defined. The origin is defined, so you will discover that when you have made enough specifications for a point to be reachable from the origin, because if we have all the information about it, for instance, if there's a point that is 180 millimeters up from the origin, that is fully defined, because you go to the origin, you go through the z-axis, and you take 180 millimeters. That point is fully defined from the origin. And if you draw a circle at that point and you specify its radius, you will see that that circle will be shown in black instead of blue. When something is shown in blue, it shows that there are still some information about it that is not fully known, and that it is mutable. But when it is in black, Fusion 360 is telling you that every information we need about that is known. So as much as possible, you want all your drawing elements to be in black. Sometimes it's not possible to make all of them in black. In fact, there are elements that I think should be in black that I'm still surprised it remains in blue. But usually, when all the information about a drawing element is known, Fusion 360 is going to help you by letting you know that that thing should look, by making that thing to happen in the black. I think we have spent 50 minutes. What we are going to do is that we're going to take a break, and the break is going to last for 20 minutes. So at 10 minutes past 9, we will start. If you come 3 minutes late, you are going to have missed 3 minutes of lecture. I'm not going to wait for you. The times will be kept. When we promise you time, we are going to keep it. We are going to keep to our side of the bargain. So if I tell you go for a break for 20 minutes, please don't go for a break for 23 minutes. Come on time. In fact, come a minute before the time so that you are settled and you can continue with the class. So we can leave there. So if I will check all the things you have put on the chat room for now, if I see anything there, I may respond, but I will read it. Thank you. See you later. Welcome back. So we are looking at a connecting rod, and I told you we are going to do a demo of this. When we finish the connecting rod, you will see that we are going to arrange it in a number of cylinders. In this particular case, you have a picture of an 8-cylinder engine. The connecting rod we created could be replicated and assembled with other components, including crankshaft and piston. Using the assembly facility in Fusion 360, we will animate a working engine with proper firing sequence. And this is what it will look like. And you will see that even the connecting rod is looking different here. We have a place where we can cut it into 2 and screw it together. You will see how we will start with the connecting rod we just looked at, and how we get to this type, and how we put everything together in a practical engine. This same can be assembled in a V engine using the same cylinders, the same connecting rod. I did a complete video of this in Vimeo and YouTube. It's now like 10 years ago. I don't know whether it's still there, but we are doing better things now. But if you still have the time, you can take a look at that and see. And so that is what we will do. What I'm going to do now is that I'm going to launch another. I'm going to close this and launch another a PowerPoint. And the PowerPoint I'm going to launch is what I'm going to use to demonstrate for you some of the ideas that we have talked about, because I will open my I will open this Fusion 360, and then you will see. Let us take a look at this IC engine then, and then do a slideshow here. I'm not going through this class now. I just want to pick some of the pictures that I need for you to see. So we have IC internal combustion engine slides, some basic skills, but I'm just going to rush through this because I'm not sure. I just want to use this one to show you how to create the connecting rod. You see that in an internal combustion engine, see how the connecting rod looks. It looks slightly differently from the one I just showed you, but that one I showed you is the base. After we have created that one, we can create this one from that one. And you will see how we move from one to the other and as we go on in the classes. The new one can be broken into two, and a mechanic can put them together using bolts and nuts, as you have seen. That's what there will now be the connecting rod head, and there is a connecting rod main. So there will be two components that will make together make the connecting rod. This is an example of a piston. So which you will do too. This is my own piston. You will do your own. I will show you how I did this one, so then you can go and do your own. And then this is the single engine crankshaft. The multiple engine crankshaft is just a replication of this, rotating them from each other to make the crankshaft, as you will see. Okay, for instance, it may be difficult for you to know that this complicated crankshaft is coming from this single one. So this complicated crankshaft came from that single one. That is the beauty of component assembly. In component assembly, you can make things that look exceedingly complicated, but they are based on very, very simple ideas. And that is how everything in this world is. The things that look complicated, they aren't as complicated as they look. They just look complicated to you. By the time you understand how to take one step at a time and arrange them, you will find out that there are things you might be able to do. So this is where we are going to stay. I'm going to conclude today's class by helping you to be able to do this, connecting rod. So let us just go to this one. Okay, so in the first thing to do, sketching the connecting rod, is that you do 1, 2, 3, 4, 5, 6, 7 circles in those locations. I will do them. You'll see how I do them. And then after that, after that, you are going to do some things and you will extrude and get what you have on the left-hand side. But later on, you will see that what we really want is the connecting rod on the right-hand side. But if we can do this one today, then another time we will see how you add the complications that you see here to it and make it two part. These two connecting rods, the differences between them is very simple. Now, this is the kind of question I can ask you in an example. I can tell you to start with the connecting rod here, which you already done, and make this one in an exam. If you are not the person that did this, you will find it, you will now be starting this from scratch. You will fail that exam. But if you did this, you will see that to now add this extra facility to it is something you can do under exam condition. So that is the kind of ways I ask my question. So if you are lazy during the time, you are also going to fail the exam. There is nothing that can save you in the exam. If you like, even fast, it won't save you because it's laziness. Laziness is not going to help you, whatever else you think you can do. So what I'm going to do now is that I will stop this. And fire up my. Let me just even switch that off now. I'm going to fire up my Fusion 360. Where is it? Fusion 360. Oh, this is my Fusion 360, and I will use this my own bench to demonstrate a lot of things that I've been talking about. And then after I've demonstrated that, I will now go and do that piston from and that connecting rod from scratch. Like, let us start with the preferences issue. So this is where my picture is. It's if I hover around it, it brings out my name in full. If I click on it, I have things like Autodesk account, preferences, my profile, share fitness. So let us just go to preferences. If we go to preferences, you can see here that the default unit for new design is millimeters. But let us even go to general preferences. You can see that the default language is English. Right now, there are other languages that are there. There's English, German, Spanish, French, Italian, Japanese. I am hoping that some of us can work and put Yoruba there. If we put Yoruba there, then somebody who is not even very well schooled can use maybe a tiler that didn't understand English, can use it to do his tiling. So that kind of thing will be done. But there is no reason why Yoruba cannot be one of the languages here. So space, the mouse driver, auto select, design, and then you have here, in this one you have Z up. If we click that arrow, you'll see that it could have been Y up, but why choose Z up? Animate view transitions. Most of the things that are here, you don't need to do anything. The choices made for you are okay. But there are situations where you may need to do things. For instance, default units. When you come to default units in your design, if you take default units in your design, now I chose millimeters. You could have chosen centimeters, you could have chosen meters, inches, or feet. All those things are possible. So I decided to stay with millimeters. And there are several other things you can select there. So those are things that are possible to select. You can play with the other things and see. But now when you come to the to this place, to this center place, you can see that is the orbit there. You can see that is the look at. You see the pan. You see zoom in and zoom out. And then you see the display settings, the grid and snaps, and then viewport. All those things. I'm not going to use, I can't explain everything to you. I don't know everything. I only know the ones I want to use. And I promptly forget them after I've used them. So if I have to explain to you, I have to read them. So there is nothing, you cannot contain too many things in your head. Just contain whatever you can contain in your head. So here is where you can set your display settings, and you can, like that, in the display setting, you can set the visual style, the environment, how the environment looks, effects. For instance, in the effects, you can check whether there is a ground plane and whether there is ground shadow. Like now, I have a ground plane, but I didn't set ground shadow. If I set ground shadow, see what will happen to my drawing. You can see now there's a shadow on this drawing. I can remove that effect and remove the shadow. If I don't want the shadow goes, and so on. But you can, if you don't select ground plane, then you cannot select ground shadow. And then here, okay, another thing I didn't tell you is that in the camera setting, you can decide to select the orthographic or perspective. So you can choose that. So there are things you can select there. So another thing I want to show you is that here, when you look at the browser here, the browser here shows you, from the browser, you can see everything that I've done here. And if I want, I can play back the design, but I don't want to do that now. What I prefer to do, let me see whether, but that maybe it's not a bad idea. If I go back to the beginning, I can just click. If I can keep clicking, it will show you. I can show you how this drawing, how all the components of the drawing are made up. Let me just see whether I can make this bigger. Mm, Let me make it bigger. Okay, so I'm playing back the video of how the drawing was done. So you can see that I'm constructing the base. I'm constructing one base. You'll see that once I finish constructing one base, I will not construct another base. I'm just going to make a component of it and make more of the bases. That's it. So I've just constructed the armrest. Then I will align it so that it fits into that hole where it belongs. So it's not a component of its own. So I have two of them now. So you can see one arm there. So you can see the bench hanging in the air. You can see a replication of the arm and the base. And what we need now is the backrest to come in there. Before the backrest, I showed how the reinforcements are arranged in the arm. I didn't show those reinforcements in the base, but I'll still show them to you. So this apparently is the playback. You can actually make this to happen like a video. So it keeps a record of what you did at what time interval. And now here I have reinforcement one, arm one, reinforcement mirror, half arm mirror, concrete base, reinforcement two, arm two, concrete base two, seat slab, steel reinforcement, backrest, and back reinforcement. What I want to show you now is that I can just go to let us say I look at the seat base, the seat slab. On the seat slab, I can go and set up the opacity control. If I set up the opacity control of the base slab, let us say I put the opacity control at 30%. So when I put opacity control at 30%, you can now begin to see the reinforcement inside it. But if I want to even make it clearer, I can set the opacity control at 10%. Oh no, that one is, maybe I should increase the opacity control instead of reducing it. Opacity control now at 80%. Oh no, it should be less. C slab, opacity control, 10%. So you can see how you are almost not seeing the slab again, but you see its reinforcement. You can set the opacity control of the arm one to 20%, for instance. Go to set the opacity control to 20%. You can see through, so you can see through it as if it is transparent. So even things that are hidden inside can be shown. These are things you cannot do by picture or by any other means apart from three-dimensional solid modeling. Three-dimensional solid modeling is different from taking photographs. It is an actionable piece of drawing that you can do analysis, simulation, animation, and computations and design with. Okay, so that is this. But that's not what I want to do now. What I want to do now is that I want to do the connecting rod from scratch. Now, I will do it from scratch as much as I can, but I've sent you the 10 minutes video, where I did it without any pressure. When I'm teaching in the class, I'm not as coherent as to as compared to when I'm doing it alone and I'm recording myself in the comfort of my room. So when I'm doing that, I can do a much better job. What I want you to notice is that if you look at what I'm teaching you in class and what I sent to you on in the MP4 video I sent to you, you will see that there are many things in Fusion 360 that can be up to 20 different ways of achieving an end. So if I create my circle by specifying the center and radius, I can decide to create my circle by specifying 3 points of the circle. I can specify 2 diametric points and so many things I can do. So there might be up to 5 different ways of creating a circle. And if I created one circle and I want to create another circle, I can go back and pick the icon to create it, or I can remember that there's a marking menu that I can automatically instantiate and to do it. But let us not talk too much. Let us just start by creating a new sketch. So if in the design here, if I choose a new stuff here, and let's see what I need to just create a sketch. I'm even not saying where the create sketches now. Solid, create. Aha. So under the solid, I was looking for an icon, but there's no icon there. You can create a sketch. So you create a sketch. That is the second item when you select the create. So when you want to create a sketch, the first thing that you see is that you have an XYZ coordinate system with the XY with this one is the XY plane, this is the YZ plane, and this is the ZX plane. All those ones are done, and you see that the X-axis is red, the Y-axis is green, and the Z-axis, which is the vertical axis, is blue. Notice all those things. Those are given to you immediately, and the origin is defined. So you can use that defined origin to define anything else. Like I told you, I have to decide, since it's a sketch, I would choose any of these 3 planes. I decide to choose the YZ plane as the plane I want to use. If I click on it, immediately it gives me the face. I'm now facing a 2-dimensional plane, and this is the YZ plane. Now you can see it is the YZ plane because the Y-axis, sorry, oh no, this is not, this is the XZ plane because this one is red, which is, and then the other one. But I want to go back to the 3-dimensional thing. So this is the X and Z plane. The Z plane is green. So let us go back and look at that plane, XZ plane. XZ, let's just see this one. Okay, well, interestingly, what I have is not the XZ plane, but the YZ plane. So this is the YZ plane that I have here. I'm surprised because I expected the line there to be blue, but the color thing is a little bit tricking me now. But so the first thing I want to do is to pan. So I want to pan. To pan, I will take the pan item here, the pan inside the navigation tool set, and I will move this thing down. So that's, I panned it. So having panned it, what do I want to do next? When I'm done with the panning, I use escape to go back. I want to create 3 circles. The 3 circles I want to create are at the origin, radii 50, 60, and 73. Those 3 circles have radii 50, 60, and 73. So I can start with the 50 radius. So I use the icon here, center diameter circle. Click that, bring it here, and then I want the radius to be 50. So once I expand that, I put the radius as 50, and it is there. So that you can see that immediately that is in black. That shows that every piece of information needed about that object is known. It knows its center, it knows its radius. And the center is at origin, it can locate that origin and can locate the radius. So the next one is another circle radius 60. So if I right click on my mouse, the last command, which is the center diameter circle, is repeated. So I put again, I want it from this center, and the radius is 60. Okay. Again, as you can see, it's black. The next thing I want is to create another circle again. I'm going to right click, center diameter circle. Yeah, I could go back and pick the circle, but this is faster to do it this way. So it is 73. So I've created the first 3 circles. The next circle I want to create is one that is 20 millimeters in diameter, and I want it to be vertically up. But I would deliberately not put it vertically up, and you will see what will happen. I will deliberately not put it vertically up. I will just put it around here. So I will create a circle, center, and I'm deliberately offsetting it from the center. So, but I want it to be 20 millimeters. Don't forget that I want this circle to be vertically up, and you will see how I'm going to get it vertically up. Another one is higher than that. It is 10 millimeters in diameter. Let us put it on this side, and it's 10 millimeters. Okay. Then I have 2 more circles. One is 32. The other one is, and the inner one is 15. So I have 2 circles, center diameter circle. One is 32, and then there's an inner one that is 15. But I will not create that. I want to use some other method to create that. So let us now see, but I want all these things to be vertical. How do I do it? I can go to the constraints. There is a constraint here called horizontal vertical. So if I choose it, I pick this center and I pick this center. So it has been constrained to be on the vertical axis. If I pick again this center that I've just chosen, and I pick this center with that same thing, it is in the vertical, this same thing, this one and this one I've just chosen. So all the circles now are centered on the vertical axis. But out of the 6 circles I've created, you can notice that 3 are black, 3 are blue. The reason why they have seen blue is that it knows they are vertical, but it doesn't know the distance from the origin. So the first one is 50 units from the origin. So I'm going to take my dimensioning tool. Dimensioning tool, where are you? Where are you? Dimensioning tool. Let's see. Dimensioning tool, where are you? Create dimension. Is it create dimension? If I make it bigger, let me make it bigger. I will see the dimensioning tool. Yes, the dimensioning tool is there. So if I choose take the dimensioning tool, and I now say from here, from this center to this center, I want it to be 50 units. If I want it to be 50 units, I put 50 there. You can see now that immediately this circle is now black because everything about it is known. It's no longer mutable. The next one is 100 from the second line. So I choose the dimensioning thing is still active. So I choose this, I bring it out here, and I want it to be 100 units. So it has thrown it off there. And then I want the distance between this one and the origin to be 180. Units. So you can see now these are all there. Now I'm done with the dimensioning thing. I deliberately didn't create the second circle here. So if I want a circle here, I want to offset that circle. I want to use an offset. I can say I want to an offset on this circle, and I can offset it outside and I can offset it inside. If I offset it inside and I say I want an offset of minus, if it is 10, that is 20 from, I want an offset of minus 6. This is -6, okay, or -7. Depends on the dimension I'm using. So I've decided to offset it. So you can see, I didn't create that inner circle. Instead, I created an offset from the outer circle to get the inner circle. And that is something that you can do, because that is that creates the circle, because the offset of a circle is still a circle. So I have created all the circles that I need. So the next thing I want to do is to create a line that is tangential to these two circles. If I want a line to be tangential to these two circles, what I will do is that I will just draw an arbitrary line, first of all. I can draw a line near them. So if I'm happy with that, I say yes. So you can see that that line is near these two circles. So what I'm going to do is that I'm now going to use the constraining facility. So I choose the tangential constraint. I want this line and this circle to be tangential. So you can see that it is the line that moved. The line that moved because the line is mutable, but the circle did not move because the circle is immutable. So that tells you when something is mutable, if there is a need for one to move, the mutable one will move, the immutable one will be static. If both of them are mutable, any of them can move. So you can see that if I make this big, you can see that between this circle and this line is still not tangential. So I can do that again. I take my tangent, the tangent thing is still active. I can choose this and then choose this. And you can see that it is now tangential to this. So you can see immediately, even the line itself is black now because it is tangential to two things. So it is a known line and everything about it is known. So it is no longer mutable. And I'm going to trim the excess distances here. So I use the trim tool. I remove this. And then I can pan, okay, I can take a pan handle. If I take a pan handle, I can use the trim tool again, and I can remove this extra material. So if I want to show the whole thing on screen now, and this is what I need to show, you can see this is, so I want to do this same tangent on this other side. It's a symmetrical thing. So I want this thing to come to this side. I can do the drawing the way I just did this one by choosing a line here and let it be tangent and so on. But there's an easier method, and that method is a mirror. So see how the mirror is used. I click the mirror. The first thing, it gives me a dialog. The mirror, the first thing I need to choose are the objects to be mirrored. So I select one object. It is that one object I want to mirror. I don't want to mirror any other thing. So the next thing I need to select is the mirror line. I want to select a mirror line. Where should the mirror line be? The mirror line now is the z-axis. So I can go to the origin and I say the mirror line I want is the z-axis. So with the z-axis as the mirror line, I've chosen it. So if I'm okay, you can see that thing is perfectly mirrored. It's perfectly mirrored. With the mirror done, the next thing I want to do is to do some more trimming. I want to remove the unwanted parts of the circles I created here. And I want to remove this one here. So you can see that in the center now, we have a whole path. And in this path, I'm going to do something else. I'm going to do an offset of this whole path. I will do it out by 5 millimeters. So I can create an offset. And this whole part is a single part now. I want to offset this, and I want to offset it. I can offset it inside, I can offset it outside, or I can select the particular amount of offset I want here, because it is taking the outside as minus. So I'm going to offset it by -5. -5. There. That gives me an offset here. So with that done, the next thing I'm going to do is that I'm going to create a spline. I'm going to create a spline, I want the spline to start from somewhere around here, to go around here, and to end around here. And if I'm happy with that, I said, okay. So, and I want that spline to still be tangent to the original big circle there. So I take my constraint, I take this and this. I've not been able to make that happen here. But if you look, when you look at the video, you'll see that I did the offset. So because it's not choosing it, so I'm going to take a pan and do it manually here. That one, let that one be off. I want this. Aha. This. No, I want to create this and this. But it's not, for a reason, it's not giving it to me. So what I'm going to do is that I will move this one manually. Well, I'm having difficulty here. I'm going to turn off the whole thing and start again. So I want to delete this line. So what I want to do is to take a spline here, because I don't have a lot of time. You can watch this on the video. It is better done there. So I come here, and then I want the thing to end here. Okay. I still want this thing to be tangential here. Let's see whether I can achieve that now. I want this to be tangential to this. Okay, so it accepted the tangential lines now. So everything is okay. Okay. So again, this, what I have done here, I want a mirror on this side. Just the way we did the mirror before, we are going to take a mirror object, a mirror icon, and it says us what object do you want to mirror. It is this we want to mirror. This one. Then the mirrored line is the z-axis. So it has mirrored it. And if we're happy, we choose it. So it has mirrored it. So you can see the mirror. So with those mirrors done, the next thing to do is to do some cleaning up. I can remove some unwanted lines. So I've removed that unwanted line, and then I can pan to the bottom and remove more unwanted lines. Oh no, before I remove unwanted lines, I have to do the same kind of, I have to do is spline here too. So I can start the spline from here. I can put it somewhere in the middle here, and I can let it end somewhere here. I'm happy with that. So I want this to be tangent to this and this. So for it to be tangent to this one, so I choose the tangent constraint, this one and this one, tangent. And then this one and this one, tangent. So it's also tangent to, so it's tangent to this, and it's also tangent to this. And again, as before, I want to do a mirror. So a mirror, this is the object I want to be mirrored. I've selected the object, and I want it to be the z-axis that is the mirror. So it is put it there. So it's okay. Now, I want to remove some more unwanted lines. The lines I don't want here includes this one. I want to trim this, trim that off, trim this, trim this, trim this, and trim this. So let us now see. I can go home and see the whole thing, or I can just use my wheel, my mouse wheel, and I can use panning to. Okay, so this is what you have now. So we can now begin to extrude. You can now begin to extrude. We have created our two-dimensional object, and we now want to make a three-dimensional object out of it. To make a three-dimensional object out of it, let us begin. We're going to extrude the top pin, the bottom pin, and the body of the connecting rod. Now, in the body of the connecting rod, this is where you may have a, please pay attention here, because you will be surprised what will happen to you when you get to this stage. Let us say I want the body to be 20 millimeters thick in thickness. And I want that body 20 millimeters thickness to be symmetrical around the base, around the plane of drawing. So I first of all choose finish sketch. So I've finished the sketching and I'm now ready to do three-dimensional extrusions. So I can choose this one all around, and that is what I want to extrude. I can create extrude, So I've already selected. Then again, when I'm creating the extrude, everything here, it knows that I've selected a profile to extrude. And then why am I starting? I'm starting from the profile plane. I can start from an offset to the profile plane. And then direction, I want it to be symmetrical. I want a symmetrical extrusion, and I want it to go through the distance of the total distance. Let's say a total distance of 20 millimeters. 20. So if I'm happy with that, and it is creating a new body, so if I'm okay with that, then the extrusion will be done. Now let us go home and see what we have done. Home. So see, that is what the extrusion has done. The extrusion has done well here, but it has erased our sketch. And we still need our sketch. We still need the sketch because we are not done with extrusion yet. This is what will frighten you if you are a new user to this. So the way to get out of this is to realize that once you do an extrusion, Fusion 360 immediately makes your sketch invisible. So what you want to do is to tell me, Mr. Fusion 360, thank you for helping me, but I'm not looking for that help. I want to see my sketch. So you can make the sketch visible back. So the sketch is visible now. Everything is there. So, and I may want to edit the extrusion. Okay, the extrusion is too thick. So I may want to edit it. Instead of 20, I want probably 15. So let me see if I can edit the extrusion. The extrusion. Where did I do it? Okay, this is the extrusion. Where's the body? My computer is. Let me leave it for now, but I will do that. I will do the correction later on. So let us take the top pin. The top pin, I can decide to extrude it again, create extrusion, and the extrusion, again as before, I'm doing it in the profile plane. I'm doing it symmetrical. I'm doing it for the total distance, and I want 30, and I want it to join the existing thing. So, okay. So you can see it has done this pin. And I want the bottom pin. I can select the bottom pin and create extrusion from it. I create extrude from the bottom pin. And I want the bottom pin again to start from the profile plane. From the profile plane, I want it to be symmetrical. I want the thing to be the full length, and I want it to go a distance of, say, 30. So you can see now we have the, so let me use the orbit for you to see it. So this is what I've created. And if I want, I can turn off that sketch because the sketch is disturbing you from seeing the full picture. So I can make that sketch invisible. So this is what you now have. that we have created. So this is how to create it. But you can watch the video that when the class is over. But I've sent a much better video that I did without you people being in class. When you're in class, you make me perform at a lower level than I can when I'm alone by myself. So this is it. So I will want you now to spend the rest of the time, go to the chat room and ask me specific questions on what we have done. And you will be given access to everything else you need at the end of the class. So chat room now. So somebody says I should make it full screen. Okay, you can. You don't worry. You will see it in the one I've sent to you. So will the video be sent to us, to our course reps? Oh, both. It will be available in both ways. So don't worry. You will see the video. So somebody wants to know when to use splines. It's experience. Sir, is the project done individually or a group? It is individually. You do your projects individually, but I'm not preventing you from having cooperation, but you cannot submit somebody else's work. If 5 of you submit the same work, I will divide the mark by 5 and give you 1/5 each. So I want to see how you think. Don't let people copy your project, because if they copy your project, I won't know who copied the other one. But it doesn't mean that you cannot ask for help from your friends. Any further questions? And we use any plane you like. Okoyemi, use any plane you like. Yes, Shobayo, the video will be uploaded. If you copied, I will know, and I will punish you. Well, great Gochuku, check with your class rep and let him contact the person who works on the website for me. And if you are not able to log in, check with your other classmates who can log in. Great. You see, I have 2 more minutes and I will wait for you. Are we doing anything theory, like theory questions? Fawaz, I'm not going to answer that question. Just obey the instructions for now. Don't ask me any other questions in that direction. Just know that this course is practical and you are going to be tested on your ability and skills. So if there's need for asking theory, there is nothing stopping me from asking theory. So, but the emphasis will be on what you can do, not what you can cram. Stephen Akinyele, everything you are taught, you must pay attention to every detail. And you must go beyond that and learn more. Well, it appears that I've answered all the questions that have been posed. And I will say, have a nice day. And make sure that you start working on your project, your first project, and it will be due June 11. After June 11, I'm not going to take it. You are working on another project. So there will be at least 4 or 5 projects between now and the end of the class. So bye-bye now.